Hello everyone, welcome to my channel Infinity Minds where maths is made easy. Today we shall be taking up chapter number 4 Quadrilaterals of the first part of Ganita Prakash. Okay, so without any delay, let us begin. Let us first try and understand as to what do we mean by the term quadrilaterals. A quadrilateral is one of the most common shapes in geometry. We see quadrilaterals everywhere around us in books, windows, mobile screens, blackboards, kites, and tiles. Understanding quadrilaterals help us learn about shapes, angles, sides, and patterns in mathematics. Definition of a quadrilateral. It is a closed figure made up of four sides, vertices, and four angles. In simple words, any polygon with four sides is called a quadrilateral. Now see students, first of all, let us understand as to what do we mean by the word polygon. A polygon is a simple closed figure. Okay, it is a closed figure, so made up of line segments. If a closed figure is made up of line segments, it is called a polygon. So when it has four line segments, there is a closed figure made up of four line segments, it is referred to as a quadrilateral. Now here the quadrilateral is SOME. It's the name of the quadrilateral is sum. For example, okay, every diagram carries a name in geometry. So there are four vertices which are taken and they are joined with the shortest distance you can have between two points is called a line segment. So when they are joined via line segments, what you get is a side. So okay, so there are four vertices, four sides, and but obvious they give rise to four angles. Important properties of a quadrilateral. It has four sides, the corners are the ones which are referred to as vertices, and four angles. The sum of all interior angles of a quadrilateral. Yes, one very important property we will be taking up in this chapter, that the total of the four angles is 360 degrees. Now, why is it so? Have you given it a thought? Let's have a look. See, if I am joining one of the opposite pair of opposite vertices, what I am getting, I am able to divide the quadrilateral SOME into two triangles. And I have three angles, angle 1 plus 2 plus 3 to make up from this triangle, and angle 4 plus 5 plus 6. So, but obvious, a single triangle angle sum property, sum of three angles of a triangle is 180 degrees. So, the total of its, since a quadrilateral can be divided into two triangles, so two 180 degrees shall add up to give you 360 degree. This is one very simple way to understand as to how the angle sum property for a quadrilateral works out. After all, you are required to learn, yes, no doubts over it, but it is very important that if you get the reasoning clear, then it is easy for you to remember the facts. Okay, let's go ahead. Same thing I've just jotted down. All these notes and slides, children, just message in the comment box and I shall DM them to you. Okay. Four sides, yes. How to name the side? How to name any particular side? We write the name of those two vertices in capitals and put the segment symbol over it. Line AB, or else one could have also called it side BA. Side AB or BA. AB and BA are same. There are different ways to name the sides. Next, side BC, side CD, side DA, four sides. Four angles, angle A, angle B, angle C, angle D. Yes, one can name angle as three alphabets also. Like angle A could be named as angle DAB. Yes, very much. Where the main angle that you wish to convey is to be taken in the middle. And rest of the two vertices which are at the end of that angle, like the way to the other two comes at the two ends, like this could have been called DAB or BA. Yes, we do name it, but when complete see, actually three alphabets are used when there is a need. I mean, the angle is if there is another angle attached to it. Okay, there are times where one cannot skip without using three alphabets. But as of here, it is sufficient even if I call it alone. If I just call it angle A. Supposedly there is another vertex E. So is it what do I mean by A? A also has some part with E or maybe another one. Then one has to be specific. Angle DAB is the one I'm talking about and not BAE. If there is an exterior angle or there is some other part, it is being divided. Even within quadrilateral, if you see, if I call angle CAD, if I only wish to talk about this part, then I need to make use of the three alphabet way of naming. What would be the name of the angle that I have marked now? Angle BAC. Okay. But when I am talking of the complete angle, even if I don't use three alphabets is also acceptable, and using three is of course possible. That is anyways possible. So coming back to angle A, B, C and D. Yes, diagonals. Joining of. Okay, so what is a diagonal? Joining of any two opposite vertices. Whenever you join any two opposite vertices, what you give rise to is a diagonal. Okay, so here A, B, C, D. And how does one decide on the opposite? Not just by looking, it is about alternate. What is the name of this quadrilateral? It is ABCD. So, if I pick up A, alternate. Alternates are the ones which are supposed to be, which are opposite, and it is very essential how you are naming. Like this one has been named clockwise ABCD. So it is like in the same order. If I am calling ABCD, my B vertex has to be next to A. That I call it ABCD, but I label it in my diagram as, for example, I am just discussing different points. Okay, I always take up the discussion in detail when I am explaining in my videos. So if I name it and, sorry, I name this as B, thinking that, okay, it is the same thing, ABCD only I meant. This is looking slight. Let me just write it neatly. Say in your diagram you have labeled this as C and B. No, then this is different. This would, the name of such this quadrilateral would be ACBD. Are you getting my point? The way you are putting the labeling in the continuous order, only the naming has to be done. This is what I mean. So if it is ABCD, if then it has to be B here. It is not by our choice. It is not. So if B has come after A, then it is A, B. B will come in the answer and C and then D. Okay. So just a quick round of recall. Quadrilateral polygon with four edges and vertices, number of sides 4, vertices 4, diagonals 2, sum of all interior angles 360 degrees. I hope that is clear and thorough by now. This is very basic type of, this is a general quadrilateral knowledge that you're having. Now in this chapter, we shall be doing various types and properties of quadrilaterals. The same four sides, as we keep putting certain conditions in them, it gives rise to different shapes, and then their names and properties characteristics follow. Okay, let us proceed. The first type, for example, rectangle. All of you have studied rectangle before in earlier classes in some context or the other. Fine. But now we shall be looking it as, but we never called it or made you think through quadrilateral. We shall now be thinking of how is it as a quadrilateral. If you try and think, oh yes, rectangle has always been a four-sided closed figure. It has always been a four-sided closed figure. But we never used to think from that perspective. Whatever we used to, normally children before this age, when you get questions, one very common thing that I think most of us are aware of, that each angle is a 90-degree. Yes. So that is a property of rectangle. Okay. That is a property of rectangle. that every diagram doesn't have all angles. So, but yes, a rectangle has. What else makes it a rectangle? Like we will be studying square also after this. At this point of time, it can come in your mind that, ma'am, then square is also a four-sided closed figure, each having 90 degrees. Yes, both of them carry these common features, that they are four-sided closed figure and each of their angle is a right angle. But then where lies the difference? A square has all four sides equal. Of course, we will be taking up square also after this in detail, but as of comparing the knowledge, so you always knew a rectangle has opposite sides equal. Are you noticing as I am putting the cut lines? These cut lines talks about the equality of sides. Okay, the equality in sides, that is looked up as cut. We put cut lines to denote equality of sides. Okay. Okay. So ABCD, closed four-sided figure, opposite sides equal, each angle 90 degree. Property number 1, all angles of a rectangle 90 degrees. Property number 2, opposite sides of a rectangle are equal. What I am trying to say by all this, that maybe some of the knowledge you already have. Maybe you knew it as a definition. That is what will now be called as properties. These are true facts and you are expected to remember, and we'll see what is the application. The opposite sides are parallel. Okay, now students, let us try and see. Parallel is denoted by an arrow. What do we mean by parallel? What are parallel lines after all? Two lines are said to be parallel when they are equidistant. Okay, when they are equidistant, that is, distance between them is throughout same. The distance which would be here, for example, if it is say 1 centimeter, it would be 1 centimeter throughout. Lines which never meet, okay, lines which never meet are referred to as parallel lines. So AB would be parallel to line CD. The distance between is fixed. Yes, aren't we talking about them to be equal? If the length of this side is 3 centimeter, it is also going to be 3. Yes, it is. The properties they do follow. So opposite sides are parallel. Diagonals of a rectangle are equal in length and they bisect each other. Diagonal we just discussed, joining of opposite vertices. The length of BD, if you measure this, whatever, supposedly you measure with a scale, the length that you will get it to be equal to AC. The diagonals are equal in length and they bisect each other. Bisect means two equal parts. Okay, say if it is 7 centimeters, this would also be 7, and they would meet at such a way that they would meet at 3 point midpoints. That's what we are trying to say. Okay, so all of these properties you are required to memorize, you've expected to learn. Okay, so pretty easy, not difficult. What is it? Let's quickly recall. Opposite sides parallel, equal, each angle 90 degree, diagonals equal and bisect. Okay, let's go to the next. Square. A square, I'll just read out. Square is a quadrilateral in which all angles are equal to 90 degree, all sides are equal in length. Yes, we just discussed. Yes, we shall pay attention to this. Let me change the color of the pen. Yes, this is very, very important for us. We spend time understanding this. This is important. We'll come back to this. Just give a second. Properties of a square. Since square is special, all properties of rectangle also hold for a square. This is what we'll try and see. Property number 1, all sides of a square are equal, clear. Property number 2, all sides are parallel to each other. Property number 3, each of the angle is a 90 degree. Opposites, each side equal, opposite sides parallel, each angle 90 degree. What all these features were there? So sorry, each of the angle 90 degree and opposite sides parallel. Property number 2 and 3 were present in rectangle also, children, right? Opposite sides are parallel, each angle is 90 degree. But what about this property? Were all sides equal in a rectangle? No, only opposite sides were equal. Only opposite sides were equal. Okay. So, the diagonals are equal. They bisect each other. Here also the diagonals are going to be equal. They are going to bisect each other. If it's 5 and 5 centimeter, they would meet at midpoint. But there is one extra condition also, that they will meet at 90 degrees. There is one extra condition also, that they would meet at 90 degrees. That is, when they would meet, they would create a 90-degree angle at the point of intersection. At each of them, they would create a 90 degree. They would. Okay. So, one of two things we are realizing are features, are characteristics which are extra in square than a rectangle. Okay. So, that is called like a superset, something which has more qualities. For a quadrilateral to be called as a rectangle requires lesser conditions to be satisfied than to be called as a square. I hope that much is clear to everyone, right? Something can be a square, something can be a rectangle, but for it to be a square, it requires more qualities. If you say your each angle should be 90 degree, fine. That can be present for a square, for a rectangle. But if you say I want all sides to be equal, so a rectangle will not be able to satisfy the condition of a square. But can square satisfy rectangle? Can square be a rectangle? You have any general quadrilateral and you've been asked to test whether it is a rectangle or not. You will check all the features. Am I having each angle to be 90 degree? Then also it can be square or a rectangle. You will check, are the opposite sides equal? It can be then also you never, maybe it's a square or rectangle. But if you check opposite sides are equal, it is a rectangle. It may be a square also, but for sure it will be a rectangle. Okay. Square is a special type of a rectangle. All properties of rectangle holds for a square. What is more important for you is this. Properties of a rectangle, all properties of a rectangle holds for a square. If you have to think of all properties, can you say all properties of square also holds for a rectangle? No. For something to be a square, it should satisfy the condition of all sides to be equal. It should satisfy all the diagonals meeting at 90 degrees. So, square is containing extra conditions. Hence, every square is also a rectangle, but clearly rectangle cannot be a square. Try to understand this fact, children. Okay. Okay. every square is also a rectangle. For square to be something to be a rectangle has to satisfy lesser condition than rectangle to be something to be a square. Rectangle will conditions will come earlier than square. All properties of a rectangle will hold true for a square, but not vice versa. Okay. Let us proceed. Okay, property number 5. Diagonal system. Diagonals of a square divides the angles of the square into equal halves. This can be expressed as diagonals of a square bisect the angles of the square. Okay, one another point. Yes, as this is also an extra condition which is not anywhere, well, not there in the rectangle. The diagonal AC bisects the corner angle A. That's obviously this is 90, so 45, 45, and this is 45, 45. Diagonal BD bisects angle B, bisects angle D. The diagonal bisects its own angles from which they are arising. Okay, that's what property 5 is talking about. Yes, this has been picked up straight from your Ganita Prakash. Let's read. I am an Indian, I am a Malayali. This is one of the cartoons discussed. Wait, which one of them are you? An Indian or a Malayali? How can you be both? Logically, if you see, if a person is an Indian and then person is further telling the language it can speak on. The relation can be pictorially represented using a Venn diagram. We have seen these diagrams before. In a Venn diagram, a set of objects is represented as points inside a closed curve. Typically, these closed curves are ovals or circles. For example, the set of all squares is represented as this. Each point in the region represents a square, thereby covering all possible squares. Since every square is a rectangle, the Venn diagram representation of the two sets will be this. Venn diagram this year has a big role to play. This is the first time Venn diagrams have been put. So it is important for you to understand. First of all, you should be clear what we've just discussed. That a square can be a rectangle but not true vice versa. As for rectangle to be a square, try to understand it has more conditions which it may not satisfy. So square is a rectangle. So square can come inside rectangle. By this example, it is trying to say that, see, you could satisfy both the conditions, as it is saying. If somebody is an Indian, somebody can be Malayali also. But not true the other way. Every Indian may not be Malayali. You're getting, by this example, they are trying to say that for Malayali person is an Indian also. So if there is a circle representing Indian, somebody is an Indian. We have a circle, big circle I'm drawing, say, which is stating that, okay, all the Indians will come and stand in this circle. So if we are talking of Malayali, Malayali would say, yes, I am also an Indian. There would come a Punjabi, he would say, I am also an Indian. So I never wanted to take up such an example, is there in your textbooks, or any other person, if you may say. So all these are part of being Indian. Being an Indian becomes a superset. It takes care of all of these. You may be a Punjabi, still an Indian. You will be a Malayali, still an Indian. But not true vice versa. I can't make a diagram like this saying that Malayali is a superset and every Indian is part of superset. Every Indian is part of Malayali. You are an Indian, so you know. Every Indian may not be Malayali, but every Malayali will be considered. Very similar thing is there. So every square can be a rectangle, but not true the other way. Okay. The properties you're going to understand and you're going to represent them simultaneously through Venn diagrams, where Venn diagram itself is the first thing you should be clear on as to what do we mean by Venn diagram. That if their Venn diagram, first of all, it means kind of in circles, ovals, you're going to represent the aspects. So something which is logically, if you see, this is the larger group, the smaller one is trying to say, I am part of you. Okay, I am part of you. And the larger one is not part of this. Okay, let us proceed. Now the third type of quadrilateral is what we are going to study. Are you realizing the first two we have already covered, starting from rectangle and square? To be honest, one can actually start with the parallelogram. There have been times, in fact, in the old books, we used to start in your previous textbook. Mainly, you've started with these because these are the two shapes you are already used to. These are the two shapes children are used to. They've done it in the past. So we now come to one new term, the third type of your quadrilateral, a parallelogram. A parallelogram is a quadrilateral in which opposite sides are parallel. Oh, square and rectangle, both of them had this condition true. Square and rectangle, both of them had this condition true. So that means they can be called as parallelogram. Yes, a very big yes. They both are parallelogram. And parallelogram in turn is a quadrilateral. They were also being called. Yes, that's the hierarchy chain. That's what is being followed. They both are part of parallelogram. They come under the heading of parallelogram, and parallelogram is a four-sided quadrilateral, which only has to satisfy a very simple condition of opposite sides to be parallel. The definition, now children, get one thing very clear. This is your definition of your parallelogram. Now coming to properties. This also talks about opposite sides to be equal. This is very much the condition of your rectangle, children, and square being a rectangle also satisfies. Square is a rectangle and both of them are now part of parallelogram. In a parallelogram, the adjacent angles add up to 180 degrees. Okay. There also, if you actually notice, 90 were becoming 180. But here it is not 90. No. If you notice, this is an obtuse angle. And this is an acute angle. Can you see the shape of an acute angle? And this is an obtuse angle. It is an acute obtuse combination that one has in a parallelogram, and they would add up to 180 degrees. Very same for this side also. Okay, acute obtuse. It is saying adjacent. Let me name A, B, C, D. Adjacent are next to each other. So not just A and D are adjacent, B and C are adjacent. A and B are also adjacent. Yes. A plus B, B plus C, C plus D, D plus A. Of course, angle symbols would come. All these individually, they would add up to 180 degrees. That's what is being conveyed. Adjacent angles adding up to 180 degrees. Sure. Okay. Next. The diagonals bisect each other. Diagonal BD and diagonal AC would meet in such a way that they would meet at the midpoint. Okay. They would meet at the midpoint. What does it mean? So is it same as rectangle? No, not at all. Just notice what I'm trying to explain now. Say 3 centimeter and 3 centimeter, 4 centimeter and 4 centimeter. What have I tried to say? O is the point of intersection of the two diagonals AC and BD. Diagonal BD was 6 centimeters in length and diagonal AC is 7 centimeters in length. Diagonals are going to be equal, no such condition. Diagonals, we never said diagonals are equal. We have said they would bisect each other. So strange, no? They are themselves going to be unequal. But the point at which they would meet each other at their respective midpoints. Okay? Diagonals bisect each other. Rectangle, they were equal and bisect. Now you would think, ma'am, how do you remember? It is only with experience, children, with so many years of studying. You are studying, you must be listening to watching the video for the first time. You must be going through the properties first time. It will take you time. It takes practice. Okay, it takes practice. Yes, learn up all the properties, understand, go through the video once again. This is a very important one. The first part that I will be putting up is very important. Properties, the more you understand and put it in your mind, is the best for you. With practice, write down, draw their diagrams, make all these diagrams which are looking little ugly, but they're all representing properties. You also do the same. Okay, and then you will be able to master them. It's very important to remember. And yes, beyond a point, they go little confusing. I agree, but that is how it is. It will happen, not a problem. So parallelogram, opposite sides. We quickly recall: opposite sides are parallel, equal, adjacent adds up to 90 degree, and diagonals bisect. Next, let's quickly cover up. We have already discussed this slide. Is rectangle a parallelogram? A rectangle has opposite sides parallel. All this I've just discussed. So it satisfies the parallelogram's definition of opposite sides parallel. Hence, it is indeed a parallelogram. More specifically, a rectangle is a special kind of parallelogram with all angles equal to 90 degree. Did you notice that the shape of a parallelogram in non-mathematical terms is like a tilted rectangle? Isn't it? But of course, that is non-mathematical, as I'm telling you. Like your rectangle is straight and parallelogram is a tilted one, acute angle, obtuse angle. But very, very similar with opposite sides parallel equal. Its shape resembles that of rectangle almost completely. Okay. So we were at this square was part of rectangle, but actually both are part of parallelogram. As parallelogram has lesser conditions to satisfy, that would be outer. For something to be a parallelogram, they only have to satisfy whatever we have just studied. You know, those couple of things, opposite sides to be parallel, equal and all. Yes, they both have. In fact, they have extra. So parallelogram cannot be a square or a rectangle, but vice versa. Okay, this is one small thing. Children do get confused. Try and learn, understand it, and then you will be able to apply it. To understand the relationship between the sides and angles, let us, no, not this. Okay, we'll do that later. Okay, so a quadrilateral in which now we are coming to another one. I think yeah, I'll just give the heading. The name has got left out. Rhombus. Quadrilateral in which all sides have the same length. Oh, same length was the property of square. Maybe. Can you see the shape? The way I was talking about parallelogram to be a tilted rectangle, isn't rhombus looking to be a tilted square? Okay. Yes, it is. And opposite sides parallel. All these features aren't they similar? Rectangle had this, parallelogram had this, square had it, now rhombus, another one has joined the gang. Opposite sides parallel and equal with little difference here and there. Again, acute obtuse combination. So this shape seems to be combination of all the previous ones. Let's just go through the properties once. Property number 1. All sides of a rhombus are equal. Clear. Opposite sides are parallel. In a rhombus, adjacent adds up to 180 degrees. Same as that parallelogram property. Remember? Adjacents. Again, A plus B, B plus C, C plus D and D plus A. Acute obtuse combination. Remember these keywords to understand. Diagonals bisect each other. Again, diagonals bisect each other. We are not saying they are equal. Only they bisect. Now, the diagonals bisects its angles. Now, this was the property of square where we were said this was 90, so 45, 45. But here we don't know. It's an obtuse angle. Supposedly it is 100 degrees. Supposedly the measure of A is 100 degrees. Then what we are trying to say is that it would be 50 degree each. It would get divided into 50 degree each. Now, if this is 100, angle D is supposed to be 80 degrees because adjacent adds up to angle A 80 degrees, 100 degrees. So, D would be 80 degrees because adjacent will add up to 180. So, this would become 50-50. This would become 40-40. That's what we are trying to mean by saying diagonals bisect its angles, because this property has come from square. Diagonals intersect, then they meet at 90 degree. This property was also there in square. They are quite repetitive. There's certain properties, they overlap. They are common to certain shapes and not present in the other. These properties have come from parallelogram. Come means as in they are of the parallelogram. Parallelogram also have ceased to have the same properties. These are present in square, but they are all already parallelogram. So rhombus will also be considered a parallelogram, because for something to be a parallelogram, it is sufficient to have a pair of opposite sides to be parallel. Let's move ahead. So there is a diagram. This diagram we had already studied up to a certain extent. Diagram has slightly changed. We had studied square and rectangle, but now rhombus also comes into the scene. Why are we making this Venn diagram? Try to understand. Yes, we did say square was a part earlier, so we were showing it like this, but now we have changed. It is one and the same thing, only just the way to show is slightly different. So rhombus and rectangle. Certain properties of rhombus are present in square and certain properties of rectangle are present in square. It is a mixture. Let us just see. It is wise enough to call all of them to be parallelogram. I think that is not a problem now. For something to be a parallelogram, they all are four-sided, and all of this comes under the heading quadrilateral. It's like if we say, is it a quadrilateral? You will say, what condition does one requires to be a quadrilateral? Like if in the beginning, when you never knew what is quadrilateral, it has to be a four-sided polygon. Yes, all of them are. What do I require to be called as a parallelogram? You just require opposite sides to be parallel, equal. Yes, they all would be, right? So in the similar manner, so I think that is very clear that yes, all of them would be a parallelogram. But now what about rectangle, rhombus and square? Yes. So for square to be a rectangle, it is obvious that we have already discussed so much. What does one require to be called as a rectangle? That opposite sides should be parallel, equal, each angles to be 90 degrees. So opposite sides parallel and equal. Yes, square has. In fact, square has extra. What else does one require to be called as a rhombus? That opposite sides to be parallel, all sides to be equal. Yes, square has. Adjacent angles adding up to 180 degrees. Yes, square has. Diagonals bisecting the angle. Square has. Diagonals meeting at 90 degrees. Yes, square has. Got it? So square can satisfy properties to be a rectangle, to be a rhombus, but they cannot satisfy to be square. Getting my point? They cannot, as square has extra condition. Rhombus cannot be called as a square because for it to be a square, the angle has to be 90 degrees, each angle, which it doesn't have. The moment it will have, children, then it falls to be a square only. That is the only difference they are containing. If you say I have a rhombus with each angle 90 degrees, then you are a square only. Then you are no more a rhombus. Okay. So they become superset. They have lesser. Are you noticing as we are moving outer in the outer circle, they have lesser conditions to satisfy. The innermost is having most conditions to satisfy. Okay, I think that's good enough for you to understand. Or you can repeat and play the video to go through the properties again. Okay, let's go ahead. So yes, till now what all we did were one type. If you try and see, anyways you have to move ahead also, but just like that I'm sharing, like rectangle, square, rhombus, all of them being part of parallelogram. Yes, they all had repetitive properties similar to each other, similar and whatever different you can call, they were of one type. Now this is another type of a quadrilateral. It is not related to the ones we studied. It is separate in itself, a kite. So they have shown you, you can identify this playing kite which you, okay, the kites which children have, the festival of kites and so on. So they have just tried to show you. This picture is picked up from your Ganit Prakash. That see how it actually resembles. So mathematically converting, it is kite ABCD. It's a closed figure polygon of four sides, four vertices. So it's a quadrilateral. Quadrilateral, this definition is in your Ganit Prakash, slightly difficult to understand. Okay, with two non-overlapping adjacent pairs of sides having equal length. Yes, you could mug it up as it is. Let me explain you in simple words. So, can you see a cut line, equality of sides? And yes, it is quite evident also, that is visually. But for you to understand, side AD and side CD, children, they are adjacent. Adjacent, we just had a word, no? They're next to each other. Till now, we've all the quadrilaterals we studied till now were talking about opposite sides equality. Okay, opposite side AD is standing opposite to side BC in this diagram, but they are unequal. This is the only one where the pair of adjacent side has come equal, and this is another pair of adjacent to be unequal or equal. So adjacents to be equal, and the opposites AD is opposite to BC, unequal. Side CD is standing opposite to AB, unequal. Okay, that is first point. Second, opposites, children, are two pairs, but adjacent pairs in a quadrilateral are not two. Adjacent are four. Side AD is adjacent to side AB also, if you notice, but they are unequal. Only two pairs out of the four pairs of adjacent sides are equal. First of all, you should know that adjacent are four pairs. So two of the pairs are equal and the other two still unequal. And opposites are anyways unequal. That is for sure. Property: the diagonal BD bisects angle ABC. Bisecting means this is equal to this. Whatever is the measure, say if it's a 40-degree, it gets divided into 20 each. And it also bisects angle ADC. And we are no way saying that our measure of angle B is equal to D. No. Can you see how I've made the angle marks? Second, di diagonal BD bisects diagonal AC. You know how do we solve about this BD bisecting AD? The longer diagonal bisects the shorter one. Remember, children, in a kite, every time one would be longer and the diagonals are going to be unequal. The longer diagonal shall bisect the shorter diagonal and will meet it at 90 degrees. That is this. OA is equal to OC. OB is not equal to OD. Okay. Longer diagonal shall bisect the shorter one and they would meet at 90 degrees. Clear? We'll go to the next. Trapezium. Trapezium say PQRS. Again, it's a four-sided. Angle S plus angle P equals to 180 degrees. To adjacent angles add up to 180 degrees, and same is Q plus R, 180 degrees. In a trapezium, only one pair of opposite sides is equal, parallel. Only one pair of opposite side is parallel. Only one pair of opposite side is parallel. So, same parallelogram, that family of parallelogram had both pair of opposite sides to be parallel. But trapezium is the one which has only one pair of opposite sides to be parallel. Adjacent angles are adding up to 180 degrees. Can anyone think of why? See. as the adjacent goes like this. Remember class 7? PQ parallel RS, PS acts as a transversal. So interior angles on the same side of the transversal are supplementary. Long back you had studied this fact. Now when the two non-equals parallel sides, if these are the two parallel, the other are these two, they are of course not parallel, but if they become equal, the non-parallel are equal, same length. Such a trapezium is called an isosceles trapezium. Remember the word isosceles? Triangle used to be there, where you have two sides to be equal. Here also the two sides have taken up from that, two sides are equal. Non-parallel sides equality is called isosceles trapezium. So the next property is regarding isosceles trapezium. This is present only in isosceles trapezium, that the angles opposite to the equal sides are equal. What does it mean? Let's quickly try and see. XWVU. Remember I had right in the beginning I had told you that now this is not so used to, like typical ABCD types. But if the way it is named, we have to name. Name of this trapezium is XWVU. You cannot skip and jump. You have to go in an order. First to the second, to the third, to the fourth. Okay? XWVU. So now what we be trying to say, side XW is parallel to UV. These are the non-parallel sides, but they are the equal ones. XU equal to WV. So the dotted lines are trying to say, so you are dividing it into, you are getting two triangles. Triangle XUVY and WVZ. In these two triangles, you have dropped a perpendicular. You have dropped a perpendicular, children. So this part of angle y becomes equal to this part of angle z. Angle xyu becomes equal to xyz. This side is already given to be equal. Now parallel sides are always equidistant. We just discussed it. For example, if this is 5 centimeter, this is also going to be 5 centimeter. Sides equality we have already talked. So two of the sides are equal. Class 7. It is like this. This side is equal because parallel sides are equidistant. The hypotenuse of the right triangle is already given to be equal as isosceles. That non-parallel sides are equal. That's the starting. We are talking about isosceles trapezium only. So right angle, hypotenuse and side. The RHS congruence of class 7 children. So through RHS, logically, if you see, triangles are congruent, and once triangles are congruent, CPCT, angles are equal. So angle U is equal to angle V in this case. What we mean by saying angles opposite to equal sides are equal. These are the equal sides. Angle opposite to this equal side is angle U, and opposite to this angle talks about the equality of angle U and angle V. Okay. Clear? So that is all for your trapezium. Both the last two that we have studied, kite and trapezium, are very limit specific and have a limited role to play. Okay. So yes, that's your whole sum of your Venn diagram. If you notice, we will start. You may feel it has changed. It is appearing it is changing because new things are joining the group. But it is logically conveying the same fact where we started with. Even the same very first that you started with square being a part of rectangle. It was appearing easy to look at, but it is the same thing but being conveyed in different manners. Very same is being conveyed because more are joining the group. Diagram is appearing to be different, but it is the same. So yes, starting right from the beginning, why trapezium has been put outside. For something to be a trapezium, I just need a pair of opposite sides. A pair of opposite sides. One pair. Yes, parallelogram has both the pairs. But so does it have one pair? Yes, it does have one pair. In fact, it has more. the way we have been trying to understand throughout. I've been explaining. This is the easiest way to explain yourself, children. Mugging up diagram, you will forget one day. But understanding will make you go a long way. Trapezium, I want one pair of opposite sides to be parallel. Okay, I have both. So I am part of you. Rectangle, then square, rhombus, rectangle, all three are part of parallelogram that we have already seen. Square was the intersection of your rectangle and rhombus, right? Now in this, the purple one is your trapezium. Then comes your parallelogram, green one. So the brown rectangle is part of parallelogram. Yes. The shaded one is your rhombus. Yes. Rhombus and rectangle, these two, this was the last Venn diagram we had done with this as your square. The portion shaded with your lines is your square. This is your rhombus. So intersection of rhombus, rectangle was your square. This is being picked up from previous diagram only. So only now kite is joining, as few features of kite are present. Like you had kite diagonals meeting at 90-degree feature. Rhombus has that, you remember? So some features of kite are there. Otherwise, kite is falling outside. See, this way, this I can call all of them to be quadrilaterals. These are the various types of quadrilaterals we have, children. These are the various varieties of quadrilaterals you have in this chapter. I have tried explaining you all the properties in depth. It would have been very easy for me to just quickly read through. I have penned down. This is very useful for you. All these slides, all the diagrams are there. But I have annotated while explaining. It was a must. So it would really be helpful. Do write in the comment box. Ask for a copy of it and I shall DM it them to you. Okay. So one last before ending. Yes, you could go through this flowchart on your own. Quadrilateral, their types. Trapezium, parallelogram, kite. As kite and trapezium hold separate, parallelogram itself has three varieties, rectangle and rhombus, and they both further we can have square at the bottom endmost, because square can be a rectangle, can be a rhombus, can be a parallelogram. They all can be called as quadrilateral. And similarly kite, but kite can't come under the heading of parallelogram, and so on. Okay. So with that, we shall end we shall come to the end of the first part, introduction of this chapter. Soon, where I shall be putting up the further questions. Also, all the things which are there, which are asked, I should soon be sharing the answers with you and explaining you the rest of the chapter. Okay, do go through this video again and understand the properties first properly before moving over to the questions. Like and support the channel, subscribe to get all the information at first time. Thank you everyone.